So, furthering our discussion on right triangles, so far the only thing we know how to do is solve for an unknown side when you know two other sides. Sometimes you're going to want to solve for a side when you don't know two other sides, or sometimes you want to solve for an angle. And this is where trig ratios is going to come into play. Before we can start talking about trig ratios, you have to understand the 6 parts of a triangle. A triangle contains 3 angles and 3 sides. For the 3 angles, one of them has to be 90, and the other 2 are termed acute, meaning that they are smaller than 90 degrees because they add to 90 degrees. They are labeled, when you look at a triangle, the angles are labeled with capital letters. So we've got capital A, capital B, and capital C. When we move on to the sides, we're going to be labeling the sides instead of just 2 sides and hypotenuse. We're going to be more specific with the other 2 sides. So we're still going to have the hypotenuse, but now we're going to label the sides opposite and adjacent. We'll go on to that one in a second, but there's another way of labeling sides as well, which is just with their lowercase letters. So for example, if you look on this diagram, we've got capital A here, and across from it we have side A, which is lowercase. We have angle C, and across from it we have side C in lowercase, and then we have capital B for the angle, and across from it we have side B in lowercase. Now let's talk about this hypotenuse, opposite, and adjacent. The hypotenuse we've already discussed is always the longest side of your triangle, and it's across from the right angle. And that's what makes it the longest side. The largest angle is going to open up and have the largest side across from it. So for example, if I looked at a triangle, a right triangle, see this side across from the 90-degree angle? It's the longest because this is the biggest opening here. Whereas these guys are smaller openings, so they get smaller sides across from them. Now the other 2 sides, once we've labeled hypotenuse, now we want to label the other 2 sides, the opposite and the adjacent. Opposite means across, and adjacent means beside. So if we look at these 2 triangles, what I want you to do is start off by labeling the hypotenuse. So it's easy. The hypotenuse is always the side across from the right angle. So which one's the hypotenuse in this triangle? Hopefully you guys all had a little think and you said, it's here. This would be side little c, or you could call it side AB, but it's the one that's across from the right angle. Now we want to label the other 2 sides opposite and adjacent. But opposite and adjacent to what? So you're going to always have to have what I call a target angle. It's either going to be a known angle or an unknown angle in the problem that you're trying to solve, or I'm going to specify. So this one says which ones are opposite and adjacent to angle A. So if I do angle A, I'm looking for which side is opposite angle A and which side is adjacent to angle A. I always find the opposite the easiest. It's going to be that little side A, so it's this little guy over here. This is my opposite side. And then I always just say that my adjacent is the one left over, but if you look at it, it's the one beside angle A that isn't your hypotenuse. So take a quick second, look at this guy. See if you can figure out which one's the opposite and which one's the adjacent. And again, we're talking about in relationship to angle A. Hopefully you found that this side is the opposite because it's across from that angle A, and this one is your adjacent. Now, why do we care about this? Well, we're going to be setting up trig ratios to solve for missing sides or missing angles. And those 3 trig ratios are sine, cosine, and tan. And if you dig in the recesses of your brain, you've probably heard this before: so, ca, and toa. So is used for the sine trig ratio. So it's the sine of an angle is equal to the ratio of the opposite side to the hypotenuse side. The cos of an angle is equal to the adjacent side over the hypotenuse, and the tan of an angle is equal to the ratio of the opposite to the adjacent. Now, what does that mean? Well, let's look at an example below. Okay, so I'm just going to shrink this down a little bit so it all fits on one page. It says, for the following 3 triangles, find the 3 ratios to 2 decimal places with respect to the 37-degree angle. So all of these triangles have a 37-degree angle. Okay, what's different about them is their side lengths. This one's 4.8, 6.4, and 8. This one's 5, 4, and 3. This one's 4.5, 7.5, and 6. And I just want to explore what happens with these 3 triangles. So for example, if I look at the sine of 37 in the first triangle, Sine of 37 is a ratio of opposite to hypotenuse. Now, when you can't really label these triangles yet unless you have different colors. So in all of these triangles, this guy's the hypotenuse, right? That's not going to change. When you're looking from 37 degrees, this one's the opposite, this one's the adjacent, okay? For this one, this guy's the opposite, this guy's the adjacent. For this one's the opposite, and this one's the adjacent. But that's going to change depending on what angle I look at. But let's just start with for this. So if we look at the sine of 37 for triangle 1, you're going to say it's the ratio of the opposite side to the hypotenuse side. So that's 4.8 to 8. As a decimal, 4.5 divided by 8, sorry, 4.8 divided by 5. Sorry, I'm saying this all wrong. 4.8 divided by 8 is 0.6. Then I want to move on to triangle 2. So let's do triangle 2 in this color here. So for triangle 2, actually we don't need to change colors yet. For triangle 2, we're still talking about sine of 37. So it's again opposite to hypotenuse. So it's 3 to 5. And again, to get the decimal, you do 3 divided by 5 and you get 0.6. Huh, it's the same. Let's do triangle 3. Opposite is 4.5. Hypotenuse is 7.5. If I do that as a decimal, 4.5 divided by 7.5, I get 0.6. Interesting. So the sine of 37 degrees gave me the same ratio, because all of these, if I look at these, like this is kind of in simplified form, these are all to 1, right? So when I put them in simplified form to 1, these aren't simplified fractions, but if I said as a ratio to 1, they all came out the same. Well, what if I look at cos 37? So cos 37 is adjacent to our hypotenuse, and I'm not going to go from 53, actually I forgot, so we're just sticking with the 37. But what I want you to notice is that for cos 37, it's the ratio of adjacent to hypotenuse. So it's 6.4 to 8. Now, as a decimal, 6.4 divided by 8 is 0.8. For triangle 2, cos of 37 would be the ratio of adjacent to hypotenuse, so it'd be 4 to 5, which again is 0.8. So what's your guess for this last one? Well, it's probably going to come out as 0.8. So if you look at the cos of angle 37, it's the adjacent to the hypotenuse, so it's 6 to 7.5. And if I plug that into my calculator, 6 divided by 7.5, oh, look at that, I get 0.8. Now I want you to do this last line. So what about tan? Tan is the ratio of opposite to adjacent. What is the fractional ratio? And then what is the decimal ratio for each of these? So pause the video and then come back and go through your answers. So if we look at tan, it's the ratio of opposite to adjacent. So for the first one, it's 4.8 to 6.4. I don't know why my screen's glitching out like this. And 4.8 divided by 6.4 is 0.75. And for triangle 2, opposite to adjacent is 3 to 4, which is again 0.75. And then for the last triangle, it's 4.5 to 6, which again is 0.75. So what do we notice? If there's a 37-degree angle in our triangle, the ratio of opposite to hypotenuse doesn't change. The ratio of adjacent to hypotenuse doesn't change. The ratio of opposite to adjacent doesn't change. The actual side lengths can change, but the ratios don't change. So then what happens is your calculator has these ratios stored. They know that if I have an angle of 15 degrees, that the ratio of opposite to hypotenuse will be. So if I look here, this is the trig table that's stored in your calculator's brain. So if I type in sine of 15 into my calculator, I'm going to get 0.259. Because every single calculator that has an angle of 15 degrees has a ratio of opposite side to hypotenuse of 2.59 degrees. And this is what your calculator uses to help you solve right triangles. Okay, so next off, I want to make sure that you can actually use your calculator. So we're going to type in cos of 20 into our calculator, and you should get to 3 decimal places. You should get 0.0 9. Now it's 9396, so I'm going to say 940. And if I look up on my trig table, the cosine of 20 degrees is 0.940. Your calculator just has these trig tables memorized or programmed into itself so that we can use these ratios to then solve for unknown angles if we know the ratio, or unknown sides if we know the angle and one of the sides. Okay, if you're not getting 0.940 on your calculator, there's probably your settings are off. So if you look at your calculator, make sure at the top of your screen it says DEG. That means that your calculator is in degrees. In this course, your calculator will always be in degrees. When you move on to Math 60, you're going to be able to put your calculator in radians and degrees, but for this course, we are only going to talk about angles in degrees. If your calculator is not reading degrees at the top of it, depending on what calculator you have, mine, I hit setup, and then there's a button that says D, R, and G. This stands for degrees, radians, and gradients. So if I click that button, I just want to make sure that I'm in degrees. If you have a graphing calculator, I'm trying to memorize the buttons in my head, but it's the same sort of idea. You go to setup and then you want to make sure that the degrees is highlighted. Some calculators have a button right on them that you can change between degrees, radians, and gradients, like right as one of the touch buttons. It kind of depends. If you're having troubles trying to decide how to use your calculator, just call and we can help you get sorted. Okay, but I want everybody to now plug into their calculator tan of 5. Or you can use this handy dandy trig table, and you can see that you should get an answer of 0.087. Okay, is everybody under? Well, I guess you can't respond to me. I have a hard time talking about video. Okay, so everybody at this point should be able to plug into their calculator the sine of an angle and get a ratio. Now what we want to do is be able to tell our calculator to go the other way. So what if I have a known ratio, but I want to know what angle that is? Well, I'm going to use the trig table in reverse. So to tell your calculator that I want to go in reverse, we use this button here. Okay, which is called the inverse sine. And so all that's doing is telling your calculator, instead of me plugging in an angle, I'm plugging in the ratio and I want you to give me the angle. So when you plug it in as sine 15, your calculator goes, sine 15 is 0.259. When you plug in inverse sine of 0.28, it knows that you're giving it this part of the table and it's wanting this as an answer. And so the answer to this guy is 12 degrees. So practicing that on your calculator, what you would do is you would hit second function sine, and then you would type 0.208, and you get 12 degrees. Okay, so now you know what your calculator is doing. This is all this is teaching you, is that when you type into your calculator sine 15, it's looking up what ratio you get for that angle. When you type in inverse sine 0.208, it's looking up for what angle you will get for that ratio. So if I plug into my calculator inverse cos of 0.946, it's looking up this ratio, and it's going to tell you that the angle is 19 degrees. If you plug into your calculator inverse tan of 0.364, again, it's looking for the ratio. So inverse tan of 0.364, there it is, and it's going to tell you that that ratio gives you an angle of 20 degrees. So what do the buttons do in your calculator? So the sine button gives you the ratio for that angle that you've typed in. So the sine button tells you the ratio of opposite to hypotenuse, whereas the inverse sine button tells you the angle that gives you the ratio of opposite to hypotenuse. Okay, so that's the difference. When you hit sine, it's giving you the ratio for that angle, and the inverse sine, it's giving you the angle for that ratio. Okay, so next what we're going to do is learn how to use it. So I'm going to pause this video and start a new recording so this video doesn't end up too long.